Land and sea are dark, so they absorb the sun's warmth. But ice reflects it straight back out to space. It's called the albedo effect. Filmed for a year from a satellite above the North Pole, you can see how the Arctic sea ice grows and shrinks with the seasons. This changes the amount of energy absorbed by the Earth, and this in turn can influence the climate right across the planet. Until as recently as 1997, the glacier was relatively stable. But in the last 10 years, it's changed dramatically. Seen from space, the glacier is on the right, and the fjord which it flows into is on the left. And you can see that it's retreated massively by 10 kilometres. The problem is, if glaciers continue to retreat at this rate, it could lead to the eventual disappearance of all Greenland's ice. That's 10% of the world's total. That would raise sea levels by at least 7 metres, which would flood many of the most highly populated regions of the world. Florida would be one of the worst places to suffer. The northern coast of Europe would be barely recognisable, and much of London would disappear beneath the waves. So, not surprisingly, scientists are eager to find out what's going to happen to Greenland's ice as global temperatures continue to rise. Each summer, as a result of rising temperatures, more and more meltwater is forming lakes and rivers on the surface of the ice. And this is where all the water flows, into deep shafts called moulins. Scientists have mapped the area of the Greenland ice sheet that experiences surface melting in summer. As recently as 1992, it was a relatively small area around the edges of the ice sheet. But by 2005, the melt zone had massively expanded. This is the Columbia Glacier in Alaska. Like Jakobshavn, this is a fast-moving glacier that ends up in the sea. It's 3 kilometres wide and 500 metres thick. But 20 years ago, it was nearly twice as thick. You can see the line around the valley where the ice used to reach. It's like a high tide mark. This change has had a devastating effect. Where the glacier meets the ocean, you can see the result. Chunks of ice are falling into the sea 30 times faster than before. As more and more ice breaks off, the whole process accelerates. Now, ice is disintegrating too fast for the glacier to replace it. Since 1980, the Columbia has retreated 15 kilometres. In fact, in the past 50 years, glaciers have been shrinking all over the world. The floating ice shelves that surround Antarctica are also disintegrating. This one collapsed in just 5 weeks, destroying an area of ice the size of Cornwall. There is now no doubt that the world's ice is in retreat. It's still not possible to say for certain how much ice on the planet will vanish or how fast. Although phytoplankton are no bigger than a pinhead, they're one of the most important forms of life on Earth. To understand just how important they are, take a look at them from space. Just off the British Isles, large patches of the sea are stained light green by millions upon millions of individual phytoplankton, known as blooms. These blooms appear around the world's oceans. And it's because phytoplankton are so abundant that they can affect the whole planet. But surprisingly, as well as being a primary source of nourishment for creatures in the sea, these tiny organisms help all animals on Earth to breathe. Phytoplankton can do this because they photosynthesize. They turn carbon dioxide and sunlight into energy in order to live. And this releases a very important byproduct: oxygen. This process takes place on a global scale. All these green patches show areas of phytoplankton, and they're all producing oxygen, which fills the seas and the atmosphere. Oxygen is vital to all animals, in the sea, on land, and in the air. The oceans are giant reservoirs of heat that's been captured from the sun. When heat-sensitive cameras are used to reveal the temperature of the ocean, you can see how the heat is distributed. The warmest areas are, as you'd expect, near the equator. But the ocean's heat doesn't all stay at the equator. The network of ocean currents distributes it around the planet. A warm current moves from west to east. It's seen here as an area of red and white. No one's quite sure why it happens, but we know it as the infamous El Niño, and it's responsible for transforming the weather across much of the globe. It brings torrential rain to South America, flooding the normally dry deserts. While on the other side of the Pacific, in Australia and Indonesia, the opposite is true. They are starved of moisture and suffer terrible droughts. Just by altering the flow of this single ocean current, weather across a planet is thrown into disarray for months. Yet even this isn't the full extent of the influence of ocean currents on our planet and on life.